Hi, this is Jason Molesky. Let's take a look at paired data and one-sample T procedures. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. Now, during one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took caffeine and the placebo was randomized, and at the end of each 2-day period, a test for depression was given to all 11 subjects. Now, researchers wanted to know if being deprived of caffeine would lead to an increase in depression. Now, this table contains data on the subject scores on a depression test. Higher scores show more symptoms of depression. So we have our 11 subjects here and their depression scores on the first test. We also have our 11 subjects and their depression scores on the placebo test. And then we also have the difference between those scores. And we went placebo minus caffeine because for the most part the placebo scores are greater than the caffeine scores, and that resulted in positive values for the most part in the difference column. Now, why did researchers randomly assign the order in which subjects received the placebo and caffeine? Well, researchers want to be able to conclude that any statistically significant change in depression score is due to the treatments themselves and not to some other variable. One obvious concern is the order of the treatments. Let's suppose caffeine were given to all the subjects during the first 2-day period. What if the weather were nicer on these 2 days than during the second 2-day period? Well, the researchers wouldn't be able to tell if a large increase in the mean depression score is due to the difference in weather or due to the treatments. Random assignment of the caffeine and placebo to the 2 time periods in the experiment should help ensure that no other variable is systematically affecting the subject's responses. Now let's carry out a test to investigate the question. If caffeine deprivation has no effect on depression, then we'd expect the actual mean difference in depression scores to be 0. That is, the scores when the subjects were on caffeine would be pretty much the same as the scores as when they were on the placebo, so therefore the difference would be 0. So our null hypothesis is that the mean of the differences is 0, while the alternative hypothesis is that the mean of the differences is greater than 0, where the true mean difference is defined by mu sub d, and we did note that that was placebo minus caffeine. Now, because no significance level is given, let's use alpha equals 0.05. Well, to use a paired t-test, let's first check our conditions. We note that the researchers randomly assigned the treatments placebo then caffeine, caffeine then placebo to the subject, so that condition is met. Since we aren't sampling, it's not necessary to check the 10% condition. And when it comes to the normal large sample condition, we don't know whether the actual distribution of difference in depression scores is normal, so we're going to have to do a little extra work here. With such a small sample size, we need to examine the data to see if it's safe to use T procedures. Well, here's a histogram, a box plot, and a normal probability plot of these 11 differences. The histogram itself does have an irregular shape with so few values. The box plot shows a little bit of right skewness, but no outliers here, and the normal probability plot is slightly curved, indicating there is some slight skewness. However, with no outliers and no strong skewness, the T procedure should be pretty accurate. Now, we entered the differences in list 1 and then used the calculator's t-test with the draw command to perform this test. We see our test statistic here is 3.53, and we get a p-value of 0.0027. That's the area to the right of t equals 3.53 on the t-distribution curve with 10 degrees of freedom. Now, because the p-value is 0.0027, and that's significantly less than 0.05, we reject our null hypothesis. We have convincing evidence that the true mean difference, placebo minus caffeine, in depression score is positive for subjects like these. Now, for some additional practice with paired data and one-sample T procedures, try exercise 85.